Hi, and welcome to What's New in the Geodatabase and Utility Network APIs. My name is Rich, and I'm joined today by Nip, Alex, and Aziz. So in the past developer summits, we've had two different talks on the geodatabase and the utility network. And each of those kind of provided an overview of all of the classes that are out there, as well as some small sections on what was new. So we thought about re-recording that this year and then realized that it's already available on YouTube. So if you want to go and watch them, that material is still out there. This year, what we decided to do instead is to create one talk just focused on the new changes that have taken place. So if you're new to these APIs, you might want to go watch those other talks. But if you are a seasoned veteran, everything you hear here will be new. So let's get started. We're going to talk about changes to versioning. So a real quick overview here is that versioning allows multiple editors to edit the same data without keeping locks on it. Two different types of geodatabase versioning. Traditional, which has been out there for over 20 years, that works with enterprise geodatabases, and then branch versioning, which is fairly new, that works with feature services. So there are lots of concepts behind versioning and lots of details. We do have other Dev Summit sessions that go into greater detail about how these things work. For this one, we're just going to go through pretty quickly and just do a quick overview before jumping into code. So versioning is controlled through a version manager class in the Pro SDK. And how you get it is if you have a geodatabase pointer, you call is versioning supported. And if that returns true, then it's safe to call get version manager. Now, the version manager class contains routines to find existing versions and create new ones. Once you get a version, you get a version class, and notably, this has a couple of methods on it that are important. Connect, which allows you to get a geodatabase reference pointing to that version. And of course, the version object also has routines for reconcile and post. So real briefly, what reconcile is it takes the edits that have been made to the parent version since your last reconcile and moves them down into your version. This can generate conflicts if the same feature is edited in both the parent and the child. The second part of the process is post, and what post does is it takes all of the edits you've made to the child and applies them back up to the parent. Now, it's worth noting that these are two separate operations in the Pro user interface, but in the SDK, it's accomplished by a single operation. There is a property called withPost on the reconcile description class. So if you set that to true, it does a reconcile and post. If you set it to false, it just does a reconcile. So we've made a number of small changes to the versioning API. You can now get the versioning type directly from the version manager. This is either traditional or branch. In the past, you had to go to the geodatabase to get that information and kind of infer it from the type of the geodatabase. A nice little performance enhancement is get version names. This allows you to quickly get back a list of all of the versions in a database. This is faster because you don't have to actually fetch those versions and fill out those version objects. You just get the strings. So the typical use case here is you display to the user a list of versions, version names. The user picks one, and then you open just that single version. We also support the ability to change the owner of a version if it's using branch. So we have made some changes to the reconcile API as well to provide full support for all of the options. Now, it can be a little confusing with three different properties with the name conflict in the title, so I'll cover all three even if the first one was already there. The first one is conflict detection type, and this is how conflicts are detected either by column or by row. So with by row, any edit to a feature, if that same feature is edited in the parent and the child, that will generate a conflict. And by column, it's only a conflict if the same attribute, the same column, is edited in the same row in both of those versions. The first new property is called conflict resolution method. We have abort and continue are the options. This is what happens when a conflict is detected. So if you pick continue, the next property that comes into play is conflict resolution type. Favor edit version resolves the conflict in favor of the child version, and favor target resolves the conflict in favor of the parent. And that last option is only applicable for traditional versioning. Now, the other really big change that we made to versioning is we've added support for partial posting. So this is only with branch versioning, and this does require ArcGIS Enterprise 10.9, which will be out shortly. What partial posting does is it allows you to post only a portion of your edits up to default. So this is very useful with design work with phased construction. So let me give you a quick example. Say you have a design that adds a new housing development. So say there's 20 new houses in a housing development, but they don't build all 20 houses at the same time. What happens is they build the houses as the lots are purchased and the houses are constructed. So with partial posting, after the first 3 houses are constructed, you can take those 3 records and only those 3 records and post them up to default. And then you'd post the other records as construction continued on that design. So unfortunately, at the first release, it is not yet supported with Utility Networks, Topology, and Parcel Fabric. We'll be adding that shortly. So enough PowerPoint. I'm going to turn things over to Asis to walk through an application he wrote and to show you the code of how to work with versioning.
Thank you, Rich. In this demo, I'm going to show regular posting and partial posting. First, I'll start with a regular post. For that, I will create a regular post version. Next, I'll create another version for partial post. Let me select to the regular post version. From the regular post, I would like to move 2 features outside of the camp boundary. Let me go ahead and edit. And now let me create 2 campsites. Now I'm going to hit this post button to post the local person's changes to the default version. Before hitting this post button, let me make sure I have a breakpoint in post method. Now breakpoint got hit. I got Geodatabase instance from active map, and from that Geodatabase instance I got the version manager. From that version manager I got the current person, which currently selected into the map, and the parent version, which is of course the default version. And here I've described the reconcile description. The reconcile description object has conflict resolution method, conflict detection type, and conflict resolution type. Here conflict resolution is set to continue, detection type is set to raw, resolution type is set to favor edit version, and post flag is true. Let me continue. Selections for partial posting. Let's skip for this now. Current version that reconcile is the method that posts our changes from local version to the default version. It takes reconcile description object, and with this custom alert service, we should be able to see whether it is posted successfully or not. Let me continue. With this custom message, we can say that our post is successful. Let me go to the default version and see whether our changes reflected in default version or not. Here is the default version, and here are newly moved campsites and newly created campsites. With this, let me switch to partial post version, and in the partial post version I will add 2 campsites, move 2 campsites, and delete 2 campsites. Then out of each edit operation I'll post 1 feature to the default version. We'll select 1 from create, 1 from move, and 1 from delete. Let me go ahead and select the partial post version. For partial post, I would like to work on this corner. I'm going to move those 2 features out of the boundary. Then I'll delete 2 campsites from this small camp area. And I will create 2 new campsites down here. Now let me select the features that I want to post to the default person. For the parcel posting, you need to select the features that you would like to transfer to the default person. So I'll just select one from each operation. So I'll pick one from move, one from create, and we'll pick one from this delete area here in this screen. So let me add this selection to campsite that I selected is here. And I'll hit this button to show the deleted records. And I'll pick one from here. Now let me hit the post. Again, we see the Geodatabase, version manager, current version, parent person, same as earlier. And this reconcile description object is also same as earlier. The real difference is in this partial post selections. Since we have selected 3 different features, the selections for partial posting should be greater than 0, and this pointer will get inside this if. Here we are assigning our selection into partial post selections member of reconcile description class. Once we hit this current person the reconcile, it will transfer our selection to the default version. Let me go ahead and continue. Now our partial selection got success. Okay, let's go back to default version and see the results. Here we go. Instead of 2 deleted campsite, only 1 got transferred to the default version. From 2 moved campsite, only 1 campsite got moved out of this camping area. And from 2 newly created campsites, only 1 campsite got transferred to the default version. With this partial posting demo, I'm going to hand over to Nip for topology. Nip.
My name is Nip Kwang. Now, I would like to introduce you to the new API for Geodatabase topology in the Pro SDK. What is topology? Topology allows us to spatially analyze our data as well as ensure the integrity of our data is spatially correct. Prior to ArcGIS Pro 2.6, there are 2 types of topologies in ArcGIS. The first is Geodatabase topology, and the second is map topology. Map topology is a simple topology that you can impose on simple features on a map during an edit session. Map topology will not be discussed in this presentation. At 2.6 and 10.8.1, a new type of topology called feature service topology is officially supported in the ArcGIS platform. Like map topology, we will not go into details of feature service topology in this presentation. In ArcGIS Pro 2.7 release, the API for Geodatabase topology officially became a part of the Pro SDK. This API is the focus of this presentation. The design goals of the first release of the topology API are: first, minimally complete. We will grow the API as needed over time. Currently, it is read-only. It does not support DDL operations. What this means is that it does not support adding and removing participating feature classes or adding and removing topology rules. nor does it support posting editing changes in a topology graph back to the feature space. It must be easy to use correctly and difficult to use incorrectly. We incorporated lessons learned from pitfalls and weaknesses in the ArcGIS topology API. Consistency. It must conform to existing patterns in the rest of the core.data API. Lastly, as much as possible, the API should work seamlessly for both geodatabase topology and feature service topology. Now, I would like to briefly go over the object model diagrams of this API and point out some of the key abstractions. The topology object is the entry point to the vast majority of functionality in the API. Similar to other types of dataset, you open a topology dataset via the Geodatabase object. You can inspect a topology's metadata via the Topology Definition object. For example, the topology rules that have been configured for the topology, as well as the participating feature classes name. From the Topology Definition object, you can retrieve the topology rules that have been configured for the topology. This API supports working with topology errors. From the topology object, you can inspect topology errors. You can mark errors as exceptions and reset exceptions as errors. In other words, you can promote an error to an exception, and you can demote an exception back to an error. Last but not least, you can validate a topology and build a topology graph. With the topology graph, you can perform analytical operations such as getting all the topology edges corresponding to a line feature. Now, I would like to do a quick demo highlighting some of the functionality I just covered. The purpose of this console program is to highlight some of the key classes and functions in the topology API. The first thing I need to do is to include the topology namespace ArcGIS.core.data.topology. For this demo program, I use a file geodatabase topology named Gwen-Teton. Before I can open the geodatabase topology dataset, I need to open the file geodatabase first. With the geodatabase object, I call the open dataset method using topology as the type and the topology name as the argument. This API can work with feature service topology just as easily. All I need to do is to pass in a service connection properties object with the URL to a specific feature service topology. After that, I just need to pass in the topology layer ID in order to open the dataset. Next, we'll take a look at the topology definition. The topology definition is the object that holds all the metadata associated with the topology. As you can see in the console, I'm printing out the metadata. Now we'll take a look at topology rules. To retrieve the rules, I simply call get rules on the topology definition object. For each rule, I'm going to print all the information to the console. After topology rules, we'll explore topology errors. Here, I'm getting all the errors and exceptions currently associated with the topology. In order to get all the errors due to features violating a specific topology rule, in this case, the point properly inside area topology rule, I filter for this specific rule and then create an error description object as input for the getErrors function. Notice here, I want to find any error that's within the topology extent. I can promote an error to an exception by calling the mark as exception method. In this loop, I'm passing each error I want to promote to an exception into the method. To do the inverse, I can demote an exception to once again be an error by calling unmark as exception. After topology errors, we'll take a look at topology validation. The purpose of this edit is to intentionally create a feature that violates the point properly inside area topology rule. This action will create dirty areas. In topology, dirty areas represent areas where the spatial integrity of the topology has not been validated. Now validate the topology. The result envelope via this property affected area corresponds to the dirty area. Finally, we'll take a quick look at the topology graph object. A topology graph is an in-memory representation of the topologically integrated features within the current topology. The way it works is that you call build graph, the build graph function on the topology object with an input, extent, and a callback that accepts the topology graph as an argument. It's important to know the lifetime of the topology graph object is tied to the lifetime of the callback. So when this delegate returns, the topology graph will be disposed. Any attempt to reuse a disposed object will cause an exception. With the topology graph, we can do different kinds of analytical operations. For example, we can find the closest topology node corresponding to a point feature. In this example, the point features is an object ID 66 in the 12 points feature class. Notice that this point is right at the middle of 3 edges. Likewise, we can get all the edges associated with a node. For each edge, we can get the from node and the to node of each endpoint. Furthermore, we can get the polygon features adjacent to the left side of an edge. If they are not available, we could try to get the set of polygon features that cover this edge. Now I'll let the program run to its completion. This is a quick side-by-side comparison of using the ArcGIS SDK and the Pro SDK to find the point features corresponding to a specific topology node. Notice a line 20 in the ArcGIS SDK example. In order to get the name of a topology node's parent feature, you will need to know which interface to cast to. In this case, is iDataset. Contrast that to line 14 in the Pro SDK example. The property is easily discoverable in the feature info value object. Ladies and gentlemen, this concludes the introduction to the new Topology API. Back to you, Rich.
Thanks, Nip. Next, we'll talk briefly about insert cursors. Insert cursors were added to the product to provide a faster mechanism for bulk data insertion. As such, they're primarily intended for use inside of a core host application. So you can get an insert cursor by calling table.create insert cursor, and then what you do is you'd set up a tight loop calling insert or insert ex to insert those rows into the table, and then call flush to flush the contents of that cursor out into the database. So some miscellaneous grab bag items. I won't go through the whole list. I've included them in the slide for reference material. One of the more interesting ones, though, is dataset.getPath. This is, of course, implemented on tables and feature classes, and it allows you to get the full path of a data set to pass into a geoprocessing routine using the geoprocessing API. Now, to switch gears a little bit and to go into the utility network, one of the big changes that took place in the last year was supporting non-spatial objects and associations. So non-spatial junctions and edges are used typically with telecom or with underground electric networks. Now these features, they don't have shape. They're not actually features, they're rows. Most of them are locatable on a map, generally by being contained within other features that do have shape. So some typical examples of non-spatial objects are individual fibers within a telecommunications cable, ducts within a duct bank, and ports within a junction box. So we've added some new values to the source usage type enums that you can tell which kind of non-spatial object a particular network source refers to. Now, associations are also supported. Just a quick reminder, a connectivity association allows you to connect to features or objects that are not geometrically coincident. Structural attachment is for things like attaching a transformer bank to a concrete pad, and a containment association is things like a junction cabinet that contains within it fuses and switches and bus bar. So unlike relationships and relationship classes, associations are stored within the network topology for much faster tracing, so you should always prefer to use associations if you can. We now support associations with non-spatial objects. In particular, you can, in addition to doing junction-to-junction connectivities for non-spatial junctions, you can also do an association between a junction and an edge object. And this can be, you can connect to the edge object the from side, so that's the initial point of the edge, or the to side, which is the end point of the edge, or alternatively to a point on that midspan. So we've added a %along property onto the association class to represent those midspan associations. And we also have a new API for editing associations. The old routines have been marked as deprecated, although they will still work. Using the ArcGIS.desktop.editing API, you can then now create an association description object which describes the association you want to create. And we have a full set of constructors for all the different possibilities. Note that junction edge object associations, you always specify the junction first. Once you've created this association description, you can then pass it to create or delete to make those edits. If you want to edit associations in a core host app or in a edit operation callback, you can use Geodatabase routines, low-level ones. The association object itself now has constructors, so you can create new ones, and then you call add association or delete association on the utility network object. We also made a number of tracing enhancements in the utility network over the past year. One of the most important of these is returning geometry, returning a graphic from your trace rather than a set of what could be thousands or tens of thousands of features. So the trace results are returned as what is called an aggregated geometry. Basically, it's a multi-part shape where we take all of the lines that are in the result, all of the points that are in the result, and all of the polygons into the result and return one shape for each of those. So you get this to work. There's a new result type enum. Just like all the other result types, you pass in this new enum value into trace argument that result types, and you'll get back in the result array an aggregated geometry result with those three geometries on it. Another new thing we support is filter barriers. So filter barriers, unlike regular barriers, do not prevent traversal to the source. So it's kind of hard to explain this. I always joke that you need a whiteboard to explain it. But barriers and filter barriers work the same as traversability and filters. From an end user perspective, the primary use case is to create a squeeze off. You create a temporary one just as you're doing your trace to do a what if analysis to get back different results for your valve isolation trace, and then presumably if you decide to place a squeeze off there, you would then create a feature in a separate transaction. So on the grab bag side for the utility networks, added an offset property to some of the layout parameters classes for network diagrams, extended the tier properties quite a bit, especially for non-spatial, and also with non-spatial, the utility network schema changed. The system tables that we provide, we no longer have error tables in our utility network. So now you can call this is system table supported to see if the system table is there before you can get a pointer to it if you need low-level access to those tables. So that is all the stuff that is officially shipping today, already out there. I want to talk a little bit more about what is coming in the road ahead. Now, in the past, every time I give this talk, I come up and tell everybody that the Geodatabase API is DML only, and that you cannot use it to change your schema to do data definition language operations, and you need to use geoprocessing for that. And we've gotten a lot of feedback about that over the years, and all of it is, we want to use C#. Please don't make us do this. So you may have noticed at 2.7, we have DDL available as a pre-release, and that will be part of the official product at 2.8. So for our DDL API, we have a specific set of use cases that we're targeting. Mostly it's for users and business partners who want to create and work with their own data. You know, they want to manipulate their own data sets. So for example, if you're a third-party application uses system tables and you want to create those tables in an app, if you want to create data sets or databases for storing results as you do your data processing and then delete it later, you know, all of that is the intended use. And we also want to support creating and modifying annotation and dimensioning classes, just because there's no geoprocessing tools for those. So if you're doing a large-scale operation, if you're setting up a schema for, say, a large utility project, we still expect that geoprocessing in Python are going to be the preferred way to do those large-scale operations. So the way the DDL API works in the Pro SDK is you start by creating a Schema Builder object. Then you describe the DDL operation that you want to execute using a set of description objects. So we have table descriptions, field descriptions, and domain descriptions, and so forth. You then add that DDL operation to the Schema Builder queue, and you can create and enqueue multiple operations into a single run of this tool. And you can, in fact, even chain dependencies between operations by using what's called a token object. An example here is you want to create a domain and then create a table that uses a domain in one of its fields. You can do that. And then finally, when everything is enqueued, you execute the DDL by calling the Schema Builder build property method. So with that, I'm going to turn things over to Alex to have him show you exactly how this API works.
Hi, my name is Alex, and I'll be showing a demo on creating a table through the Pro SDK. So with this new release, there is now API to perform schema operations such as creating and deleting tables, feature classes, feature datasets, domains, and so forth. So I'll be showing a way to create a table. So this is a core host application. First thing you need to do is make sure we have the correct namespaces. So the namespace for the DDL is arcgis.core.data.ddl. So now there are two main objects for DDL. One is description objects, and the other is a schema builder object. Description objects are simply that. They just describe some kind of schema object, such as a field description describes a field, and a table description describes a table. Since we want to create a table here, we would want a table description. So in order to create a table description, you can either A, pass in a table to be used as a template, or you can create one from scratch, which is what we're going to do here. So to create one from scratch, you need a name and a list of field descriptions, such as how a table needs a list of fields. So we can first off by creating an object ID field description, because tables will have an object ID field. To do that, we can either use a constructor or we can use a static method, which is create object ID field. Simple as that. And we can also, let's create one more field, a text field description. We will use let's use the constructor for this case. So to create a field description, we need to pass in a name. So let's just pass in a text field. And we need to pass in a field type. So this is a string. We can also add more properties to our field description, such as an alias. So we can just call it text field alias. And we can also pass in a length field. So let's just say the length is 100, some arbitrary number. So now that we have our two fields, we can now create our table description. Actually, first, let's just create a list to hold it. So we'll create a list of field descriptions. List field description. And this will be to hold our two fields that we just created, which is the object ID field and the text field. So now we have that. Let's create our table description. So like I said before, the table description takes in a name, which we can call test table. And it'll take in a list of field descriptions, which we just created. So now we go on to the other object of DDL, which is the Schema Builder object. So the Schema Builder object is a class that has all the APIs necessary to perform schema operations. Some of the methods are something simple like create, delete, modify, rename, and so forth. Since we're creating a table here, we'll be using create. But the first thing to do, in order to create a Schema Builder object, we need to pass in either a file geodatabase or an enterprise geodatabase. We'll just use a simple file geodatabase here that I created. It's a demo, has no tables inside it. First thing you need to do is, we need to create the path for it. So the path would just be this. We also need to create a file geodatabase connection path, which would be like so. And pass pass in the path. And now we can fetch the actual geodatabase object itself. Pass in this connection path. So now, to create the Schema Builder object, we pass in this geodatabase. So now, every schema operation that happens on this object right here will be referring to this geodatabase. So if we call create, pass in our table description, it'll create a table inside this geodatabase. Now the create method also creates something, returns a table token. This token is just something that represents the table to be created. It's not necessary for this demo. It's mainly used for like other operations such as create a relationship class, which takes a table as an input. So we won't worry about it here. So once you call create, this operation doesn't necessarily actually create the table itself. We will have to call another function called build. So this build function will basically perform every single schema operation that we have called. So we can call create here for a table description. We can call create for another table description. We can call create for a feature class description. And this build will basically perform them all at once. So the build method returns a boolean. The other returns true if every single operation performed succeeded, or return false if one or more operations have failed. So once we call that, we can even check this boolean. Let's say we want to like do something, or handle a failure or handle a success. We can do it similar to this. So let's say our schema operation to create a table succeeded. We can do something simple like print out a message saying we have successfully created our object, right? So now let's see how this works. So now we run our program. It has, oh, sorry, I forgot to call it. So we have to call our function first. Now we run it. As you can see, it says we successfully created our table. Let's just double check that's created. So this was our geodatabase. If we refresh it, there's our test table that we have just created. And now you're probably asking, what happens if it fails? So let's say one more operation fails. There's another property on Schema Builder called error messages. Basically, error messages will describe every operation that has failed. So we can loop through our error messages and print them out. Or you don't have to print them out necessarily, but you can print them out to see like which operations failed and why. So we'll do that here. So print our error messages. So now let's show you a failed operation. So now that we created our table, right? If we tried to create another table called test table in the same geodatabase, that would fail because you can't have two tables of the same name. So let's just rerun the program, which will try to create another table called test table, which should of course fail. And as such, it does fail. So now the error messages, how to read it. The first line describes the operation that just ran. The second line describes the operation we were trying to work with, or not the operation, the object we were trying to work with, which was the test table. The third line describes the error message, this failed because the table already exists. And the fourth line describes how long the operation ran for. So we can see the operation failed in this amount of time. So as you can see, all this, or in this new release, the Schema Builder object and descriptions can be used to perform operations such as creating tables and so forth. And this concludes my demo for today. Thank you so much for watching.
Thanks, Alex. So at the Pro 2.7 pre-release, we support creating and deleting tables, feature classes, and file geodatabases. So this is out there now. Now, as I record this, it's about 6 weeks ago from when you're first watching it. So we're not quite sure what is going to go into Pro 2.8. We do know a certain number of things are going in. The ability to modify tables and feature classes, to manipulate feature data sets, to rename tables, feature classes, and to create and delete domains. So you can see a list of other things that we're planning on supporting, along with they are in priority order, and you can see based on the number of question marks, the possibility of it getting into 2.8 or slipping into 2.9. So some other geodatabase things we are considering for 2.8 are update cursors, improved mobile geodatabase support, that's support for SQLite geodatabases, and then providing access to running batch attribute rules with file geodatabases. On the utility network side, we want to provide an API to work with unlocatable objects. We want to support the allow indeterminate flow checkbox for tracing, and to provide information about what field on the table is used to store the subnetwork name. So some longer term items that remain on our roadmap. Some of the bigger ones are providing a list of editing changes that have taken place on a geodatabase, as well as routines to work with sync. And then on the utility network side, support for the new named trace configuration functionality. Just some closing thoughts before we wrap up. Just to remind you that the Pro SDK is but one tool in your toolbox, and there are many other ways to customize your applications. I want to bring your attention to the Enterprise SDK in particular, because that's new over the past year. That lets you build applications on the server side, extensions, I should say. And finally, here's a list of informational links for additional reference going forward. So with that, we're going to conclude the pre-recorded part of this presentation, and now we'll open things up for live Q&A. Hi there. So before we start live Q&A, just wanted to go through and talk about some of the changes that took place between when this was recorded and now. First, on the list of Pro 2.8 DDL operations, there was a couple of objects with question marks. The one that we did manage to get in is create and delete in-memory geodatabases. The other ones on the list are going to have to wait until a subsequent release. We did not get to update cursors. However, we do have support for improved mobile geodatabase support. I'll talk about that in another slide. Attribute rules for file geodatabases, both batch calculation and validation, are up and running. In terms of improved geodatabase support, we have a new class called the Mobile Geodatabase Connection Path. You create it by passing in a URI, and then you pass this object into the geodatabase constructor, and that will give you a geodatabase that's pointing to your SQLite geodatabase. So this supports the three kinds of mobile geodatabases that we have right now. When you create it with the Create Mobile Geodatabase geoprocessing tool, if you have an online mobile geodatabase that you've created with Feature Services Sync, and finally a mobile geodatabase that's stored inside an MMPK. So one thing to note is that the get geodatabase type method returns a local database. So that is actually the same as a file geodatabase, because they should have the same capabilities. So it does return the same type. So that is all I have for addendum. We can now address some questions. So I guess while we are waiting for more, I do have a couple things that came up on the chat during the talk. First of all, differences. To get the set of differences between two versions, you call the table.differences method. Just one thing to point out is that if you are using branch versioning, you can only get the differences between the branch that you're looking at and default. Now, this is because that's the only version you can reconcile and post with. Remember, in traditional versioning, you can reconcile and post between different sets of versions. Another thing I wanted to address is on the insert cursor. That's the new capability we added at 2.8. Someone was asking how this is going to work with the utility network, and the answer is it won't be any slower. So how much faster it is depends a little bit on your data configuration. For example, if you have relationship class messaging or annotation, it probably won't save you a whole lot of time. We have seen, I would say, the biggest performance advantages with client-server databases, for sure.
So Rich, there is a question regarding creating feature classes with the .NET SDK and just confirmation on which release that will be available.
I'm sorry, could you repeat that?
Sure. The question in the chat is confirmation on which release creating a feature class will be available via the .NET SDK.
That's 2.8, and that should be shipping, I believe it's May is the official date. Actually, one other thing I noted is someone was asking about ArcGIS.core.internal.data.ddl. That reminds me to say that it is changing its namespaces when it goes into the real product. It will be in ArcGIS.core.data.ddl. So we get rid of that internal thing.
There was another question, a little more involved. If the user creates two tables within a schema builder, one that can succeed and one that will fail, and then they call schema builder.build, will the first table be created or will everything be rolled back?
Alex, do you want to answer that?
Yeah, so for if you create two tables and one fails, one succeeds, the end result will be the successful table will be created. The failed table will just result in an error, which you can see in the error descriptions variable on Schema Builder, but they will not be rolled back.
There's a follow-on question to insert cursors. Are you saying that we can now use insert cursor with Pro SDK without using core host?
Rich, you're on mute.
Thanks. Sorry, it's only been a year of using Zoom. Yeah, you can use an insert cursor inside of Pro. We recommend you do so inside what's called an edit operation callback. This will ensure that the map will refresh correctly after the editing takes place.
There's a couple questions that got upvotes before they got answers, so it's a little harder to track, but I think one of those is there an API on the SDK to get the differences between version 1 and the default version? I think we already went over this, but it wasn't explicitly on a version per se.
That's the table.differences method. So you would loop through all of the tables in the Geodatabase asking for the differences on each one.
There's another question about class extensions like Park objects. This SDK will this SDK have something like this in the future?
I think I'd like to know more about what you're trying to do with class extensions. We certainly don't have any plans to add it. If you have time to type it in now or come to the Ask the Experts area.
Yeah, I think this is probably a good time to talk about further discussions at the Ask the Experts. I think the statement at a high level is that the Pro SDK does not support that at this moment.
Actually, it's one of the most popular questions here, so I'll repeat it if you're not watching the chat. When is partial posting support for the utility network planned? Obviously, we had hoped to have that in the first release. That will not come until at least we get a new version of server, because it does happening server side.
There's another follow-on question from the differences. Does tables.differences support the difference type enumerator?
Yes, it does. And I'll say that the difference type enumerators vary depending on whether you're using traditional versioning or branch versioning. There's only a subset of the difference types that we support with branch versioning. It's all in the docs. So what's the difference between using insert cursor and create row buffer? It's just that insert cursor, if you call insert cursor in a loop, it can be faster. It uses a different underlying mechanism to insert the rows. You know, the biggest use case for it is if you're doing a bulk, like a data conversion app or something like that, right? Where you're just taking every row in a table and slamming it into a different table. Another way, of course, to do that is to use the append tool in geoprocessing. But the community has let us know what they thought about Python and GP tools when they'd rather use C#. So. I guess to repeat another one that we have in getting lots of upvotes, we have a sample for creating a version dynamically. We did put a link in the, if you look in the chat, there's a link to a code snippet showing you how to create a version. And then we don't have a snippet for it, but the routine to call is map.changeVersion. You pass in the old version and the new version, and we'll switch all the layers pointing from all the layers at the point to the old version and change them to point to the new version. Sounds like we have only a few minutes left. If you have additional questions, please visit us in the Ask the Experts area.
We'll try to sneak one more in here.
Okay, sounds good.
At least, is DDL supported on mobile geodatabases?
Not yet, but it is definitely our plan.
Yeah. In the future, the plan would be to support those on geodatabases created within Pro, but to not support DDL on offline services.
Correct. Any plans to have APIs to support diagram template creation? I don't know. I guess the answer is no plans yet, but we can certainly look into that. And are there options to create an editing listener? We do have some events on the editor that you can listen into.
I think that's all the current questions, Rick.
Okay, sounds good. Thank you guys very much for joining us today. And if you have additional questions, please, we look forward to seeing you in the Ask the Experts area. Have a good afternoon and enjoy the rest of the conference.